Section 3.3, we're going to study conditional statements. The classic one is if P then Q. If P then Q, or sometimes with symbols we use the arrow key, and this can be read P implies Q, but if P then Q. And so I'm going to create a couple statements. P, you earn an A. Q, I give you $20. And I can tell you the truth table for this conditional statement. It's relatively simple. And I suppose I could say that that's all there is to it. So there you go. But the question is, how do we make sense of this? How do we make sense that when P and Q are both true, this is true? When P is true and Q is false, it's false. And when P is false, it's true. How do we make sense out of that? What's going on there? And one way to try to make sense out of it is to think of this if-then statement as a promise that you're making. So let's just say, only pretend, that I tell you, I give you a promise. If you earn an A, then I will give you $20. That's a promise I'm making. So that's our compound statement. That's our conditional statement. And it being true corresponds to me not lying, to me not breaking my promise to you. And it being false, this conditional statement being false, corresponds to me breaking the promise. So let's take a look at these. If in fact P and Q are both true, then in fact you earned an A and I gave you $20. Therefore, I've kept this promise that if you get an A, I'll give you $20. So that's true. That stands for a promise that's not broken. What about P being true and Q being false? That would mean you did earn an A, but I didn't give you $20. And that is a broken promise. I've broken my word. And there's the false. So far, people have very little trouble with this. They think to themselves that this makes sense and everything's fine. But down here towards the bottom of this truth table, it gets a little weird. So what if P is false and Q is true? In other words, you didn't get an A, but I gave you $20. The question is, did I break this promise? And the answer is, I could not possibly have broken the promise because the condition that my promise was based on did not happen. You didn't earn an A. So kind of all bets are off. I'm off the hook. This promise is not in effect anymore because you didn't meet the condition of the promise. So whether I give you the $20 here or whether I don't, doesn't really mean that I've broken a promise. The promise can't be broken because the condition wasn't met. So in a sense, these are unbroken promises because of that missing condition. And unbroken promises are true. Another way to look at this would be if we put a false here, that would mean that I did not fulfill this. And there's no way I did not fulfill it. I kept my word perfectly fine. So if it's not false, it has to be true because these are statements. And so that's the basic underlying idea behind a conditional statement. So a biconditional statement, or an if and only if statement, is a little line with an arrow on both sides. And what it means is that if P then Q and if Q then P, it means this compound statement. It's shorthand for this compound statement. So I thought we would work out the truth table for this compound statement, and therefore we would know kind of what this means. And so P implies Q, we just did. That's going to be true every time unless there's a broken promise. And the only way there can be a broken promise is if the original condition the promise is based on is true, and the follow-through, the promised follow-through or consequence is false. So here's the truth table for P implies Q. Reversing it, Q implies P. If Q, then P. Again, the only way that can be a broken promise is right here. the assumption Q is true, but the follow-through P, the promised consequence, is false. And now we're putting these two together with an AND, but the only way an AND can be true is if both are true. So, true, both true, false, false. So the way this if and only if statement, or this biconditional statement, the only way it can be true is if both of the original statements are true or both of the original statements are false. That's the key thing to remember. These if and only ifs are true when both statements are true or both statements are false, and only then. In this problem, we're asked to form a truth table for this conditional statement. Not P implies not Q. And so we're going to need a column for the negation of P, which would be false, false, true, true. We're going to need a column for the negation of Q, which would be false, true, false, true. And then the only way that this promise that not P implies not Q, the only way it can be a broken promise if this left-hand side is true and this right-hand side, the thing the arrow points to, is false. So it looks like that's the only way the promise can be broken. The rest of the time, it's true. Here we want a truth table for this compound statement, and I have P and Q set up, and now we're just going to copy the results from the previous discussion about this biconditional. The idea is that biconditional is true when both P and Q are true, it's true when both P and Q are false, and it's false at every other time. So we can fill in that row with just understanding that idea and remembering that idea. We don't have to make it be an AND statement and do all the work each time. And now what we're going to do is we're going to have this conditional statement, P if and only if Q implies P. So given this condition, we're testing these follow-throughs. Now the only way that this can be a broken promise is if the first part of this promise right here, the first part, is true and the second part's false. That's the only way it can be a broken promise. So here we have the first part being true and the second part being false. That's a broken promise. The rest of these are okay. They're not broken promises. And so this is the resulting truth table for this problem, number 12. In constructing a truth table for this problem, we need a standard grid of P, Q, and R, those three statements, but it looks up here like we need a not P. So that'll be the 4 falses, followed by 4 trues. And then it's time for this conditional statement. If we make a promise of not P, then we're going to follow through with Q. So this is the start, and this is the promised follow through. And the way this can be a broken promise is if these guys are true and these guys are false. Otherwise, it's going to be true. So let's look for trues followed by falses, and here they are. True with a false follow through, a true with a false follow through. There isn't any other trues with false follow throughs, and so we have a truth table that is mostly true and then somewhat false. And now we have to do an AND R. So now we're at the final column in our truth table, and we're going to take these and we're going to do an AND with these. And of course an AND is only true when both are true. Otherwise it's false. We have true, false, true, false, true, false, false, false. The only three that are true are here, here, and here. All others have some fault somewhere. So here's our plan to construct the truth table. We're going to do this piece, this compound statement, and this piece, and then we're going to analyze the biconditional by putting a true whenever they're both true or both false, and a false everywhere else, and see what happens. So looking up here, we notice we need the negation of P and the negation of Q. That'll be false, false, true, true, false, true, false, true. Then, working on this one, we need not P or Q. That is this column and this column connected with an OR statement. ORs are only false when both of them are false. So we have a false here and we have true everywhere else. Then we need a P and the negation of Q. A P is here. The negation of Q is here. We need an AND. The only way an AND can be true is if they're both true. So this one's true, both true, and everything else is false. And the only way that this final statement, and instead of writing it down again, I'm just going to circle and put it here. The only way this thing can be true is if both of these individual pieces are true or both of them are false. In other words, if they match each other. But you can see they don't match each other anywhere. So these are false, 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 false. What this says is no matter what P and Q are in terms of truth, this compound biconditional statement is always false. So always false is a contradiction. Again, we're trying to avoid an 8-row truth table to answer this question when these specific sets of values are given for the truth of P, Q, and R. So we're going to try to fill in these things. So it looks like R, which is false, implies, and we have here not P, which is the negation of P. P is true, so this is false. We've got the double arrow, and not Q, the negation of Q is true. And so what do we have here? We have a biconditional amongst two things that are not the same, and so that is a false statement. And if you have a promise where the condition of the promise is not met, then it doesn't matter whether you perform the required consequence or not. The only way a promise can be false is if there's a true and a false. And so this is, believe it or not, true, which is probably the weirdest part of the problem.